Hey everyone, another day, another DSA problem. So today we're going to look at 3738, longest non-decreasing subarray after replacing at most one element. Okay, so the title itself is self-explanatory of what the problem actually is. So let's just look at an example over here. So we are given a nums array 1, 2, 3, 1, 2, and we want to form the longest non-decreasing subarray after we do like one replacement. All right, so let's see till here. 1, 2, 3 is increasing on its own, so that's 3 elements. And then if we replace this one to make it a 3, let's say 3 or anything above 3, then we have a length of 4. And you can check all other possibilities. That's the only one, so it's 4. So non-decreasing actually means that it can be the same element, which is next. So that's still considered as non-decreasing. It doesn't have to be strictly increasing. So yeah, in this case, we see that everything is just the same element, and that can be a possibility. So we take that length itself. So it's 5. All right, so let's just take a look at that over here. So yeah, I just mentioned the same thing, right? So we replace this and then turn it to something which is either greater than or equal to 3, and then our length would be 4, which we have here, and this everything is the same element itself, so the answer is 5. So if we were to do a brute force approach for this, it would not be optimal at all. So what we would do is for each subarray, and we know that the number of subarrays would be O of n square, right? So we try replacing the element at each position because we don't know what the ideal position is, and then we want to validate for each of those changes. So if we look at that, the number of subarrays, as I mentioned, is O of n square, and then for each subarray of, let's say the length is m, we try a replacement for each of these positions. So that's O of m. And then the validation, again, is O of m. So if we take that, that's O of m square into n square. And let's say if m is like near about n, then that would make the whole thing equal to n raised to 4. And that is extremely bad, as we can see. Space would just be O of 1. And if we're doing like some kind of, if we're manipulating the list itself, then again, that would probably be O of n, but I think that's just auxiliary space. So the question is, can we do better? And yes, obviously. So let's get an example over here and try to understand what the problem is asking for us, basically. So we're told that we are allowed to replace exactly one bad element with any value of our choice, right? So I know that for every index value I, any of these like index elements could be the one that's replaced, right? So what if numsify is the element that I want to replace? All right. So knowing that, I want to see, can I actually build the longest non-decreasing subarray around it, right? So let's look at this condition. So we have 1 increasing, 3, 5, 7 increasing, and then we have a 12, which is not increasing. So this would be the element that I can replace here, right? So if I replace that to, let's say, like a 7 or an 8, then I could take that, and then this is increasing, this is increasing, this is increasing. So what is the size? 1, 2, 3, 4, 5, 6, 7, 8, right? So the answer here is equal to 8 by doing one replacement, right? So I basically go through each index and just try to check if this is like the position where replacement actually gives me the longest non-decreasing subarray. And how we're going to do that is something we'll be discussing now. Okay, so for every index I actually want to know 3 things, right? So if at this element, let's say in this case, it's an ideal situation where the next element was smaller and I could have included it. But if there was another condition, let's say what I'm given here, 1, 2, 3, 4, 1, right? So let's say there is nothing to the right of it that can be, that can club to it. So up to every element, I would just be taking the left portion of it, right? So maybe this example would have been better if there was something else beside it, like maybe a 2, and then I know I wouldn't be able to increase it, but let's see that later. Okay, so the first case is I want to see for every index I, if I extend from the left, what is the length of the longest non-decreasing subarray, which is going to end at this position. Okay, let's just take this example to understand it better. Okay, when I'm at, sorry about that. When I am at this index 0, and I'm dealing with 1, the longest non-decreasing subarray here is just a flat 1 because that's the element 1 itself. Then I go to 2 and I see 2 is larger than 1. So here it becomes 1 plus 1. That's 2. Then I go to 3 again, it's increasing. So that becomes 2 plus 1, 3. I go right here to this element, this position, and I add another one, so it's 4. But once I come to 1, it's not greater than 4, right? So this value will just be 1 itself. Okay. Yeah, so that's the condition where I'm just taking the left side of things up to that element, and I'm saying, hey, if I replace this element, then this is how much length I'd get. So in this condition, this is the value that's sort of deviating, and it's not according to the rules of non-decreasing, right? So if I were to replace this, then I would get these 4 up to here plus 1. So I'd be getting 4 plus 1, which is 5. And that's the condition of just taking the left. Now, let's see a condition where we want to change the starting element, right? So the starting element itself is the one that deviates. Now, I can't do this in the forward direction because I don't know which element exactly that I have to take. So that's where we're going to do this in the reverse order, right? Because if I go from the backward direction, at each position, I will know what the longest non-decreasing subarray length was from that position, and then I could just add a 1. But I can't do this while I'm going in the forward direction because obviously that will give the value that I can replace at the end. So if I want to see the value that can be replaced at the start, I need to do this for my right side extension part, right? Okay, so we'll keep an array, RFI, which is basically going to represent the length of the longest non-decreasing subarray starting at I, and the other one was the length of the longest non-decreasing subarray, which is ending at I. All right, so let's take an example here. So I'm going to start from the back, 3. It's element 3 alone, so the length of it is 1. Then I see 4, right? So 4 is not less than 3, so it's actually not the right value. So 4 just has a length of itself, which is 4, and it can't extend to the right. Then I come to 2, and I see 2 has a value which is greater than it to the right, right? That's 4. So this becomes 1 plus 1, which is 2 here. And then I come to 2 again, and so I see that the value of the element after it is greater than or equal to it, right? So from here, it becomes a value of 3. And then from 1, again, 2 is larger, so it becomes 4, right? Yeah. So in this case, we are looking at the right position. And let's say, so if I were to replace any element at this position, I could have replaced, let's say if I had replaced the value for itself, I could have added extra to it, right? So if I had replaced 4 with something else, let's say 2 again, it would have increased, right? And that would have changed the value that I took. So again, yeah, while we're iterating in our next pass, we will be considering that. So yeah, this is basically what we'd be getting for now. So if I saw at position 4, I could have chosen to replace 4 with something less than 3, right? And then this would have been 1 for the replacement and the length of whatever was there, right? So this would have been 2 if I was considering that position. Okay. All right, so yeah, we basically build L by taking a forward pass, and then we're going to build R by taking a backward pass, right? Okay, all right, get it. I just want to see if I did something wrong here. No. Okay, so what do we do after this? We have an array L and an array R, which are representing these lengths right now. So how are we going to use it? Okay, so we're going to traverse from 0 to the nth position. And for each index, we're going to consider 3 cases, right? So the first case that we worked on is, what if I just take the left part and I extend the current element that I have, right? So we extend the left side, and then we consider that numsify is going to be replaced by a large element because we are increasing here, a larger equal element. And then in that case, the max length would be whatever it was before this index, before the replacement index, plus the 1, which is contributed from the element that is replaced. Its length contribution is 1, right? Let's look at this condition here. Length is just 1. This is increasing. Length is 2. This is increasing. Length is 3, right? So for this position, it would have actually been 1, assuming that this was less than 3. And let's consider at this position if I'm going to extend from the left, right? So I'd go to L of I minus 1. So this was 3. Up to that position, I would take 3 plus whatever length this can add. So this would have been 4. If I change this to something, let's say 5 or anything greater than or equal to 3. Okay, and the next case would be if I extend only the right side, right? So then it would be that element that I'm changing, which is contributing 1, plus whatever, like what was the length up to this element that was the greatest from the right side. So here, 6, this is only 1. And then 2 is less than 6, so this is 2. Then this is less than 5, so this is giving 3. And we see that up till here, from the right side, we have the longest increasing is 3. And then x can obviously be anything, right? So if I do replace x to something, let's say 3 to 2, 1, 0, or anything smaller, right? Then I would have a total length of 4, right? That's basically r of I plus 1, which is for this. So that is 3 plus 1, which is the replacement at this index position, which gives us 4 again. Okay, so we have covered these 2 cases right here, and now we're going to look at the third case, right? So the third case is, let's say this element itself is something that could connect the left side and the right side. What do we do then? Let's look at this case over here. Let's fill the values of L and R and then just check, right? So I'm going from left to right. This is obviously 1. Here it's 2. I don't know what it is. I'm going to assume that it's one of these faulty numbers that we have to replace. So that would have been a number which is greater than 4, and it's not able to connect, right? It could have been, let's say this was like a 10 or something, okay? So here, it would just be 1. Again, from 4, it's 1, and from 5, it's 2, because 4 to 5, it increases. Now let's check from the right. So 5 is just contributing 1, then 4, it's decreasing, so this is 2, then 10, not decreasing, again, it's just 1, and then 2 is contributing 1, then 1 is less than 2. So again, the length of this increases to 2, considering from the right. All right, so what do we do taking L and R? Now we're going to check the case. We already checked what L is giving us and what R is giving us, right? Now we want to check the case. What if this element is something that can be changed such that the left and right can be combined, right? So this can only happen if whatever element is here, that the element before it is less than or equal to the element after it, right? Because if I had an example of something like 1, 6, 10, 4, 3, right? Then even if I replace this would have never been like non-decreasing, right? Because 4 is less than 6. But if it was the case that this was 1, 6, 10, and then we had, let's say, another 6 and a 7, then this could have been changed to another 6, and we could have had the whole thing. So this is the case that we have to check. And if it does work out, then that means for this position, I can take whatever was the length of the maximum non-decreasing array from before it up to this index. So index is 2. And then whatever is replaced here, so an additional 1, which we see here. So whatever was before it, up to there, and then the 1 which is being replaced, and then everything that was already increasing, not decreasing actually, that came from the right after it, right? So yeah, that is basically how we're going to solve this problem. And I hope you guys understood it. So the time complexity of this is basically we're calculating L, we're doing R, and then we're going to use this. So that's 3 times of n, but which is basically O of n. And the space, again, we're going to use an L and an R. And answer is just, it's going to be like one variable, which we'll be using. So that's there. So it would be like O of 2n plus that answer variable, O of 1. So whatever, it's just O of n again. Yeah, I hope this was clear. Let's just head to the code and see it. I think if my explanation wasn't good, this will help us understand better. Okay, so what I'm doing here is basically this is just a condition if our elements themselves are less than, if it's only 2 elements, let's say whatever the elements would be, then I could replace one of those elements and just make it equal to n. And if the element was only 1, then the length would obviously be only 1. So that's why we're just putting this case. It'll work even if you don't do that. Okay, the same thing here. I'm going to initialize L. And by default, everything has a value of 1 because it itself can be the increasing subset starting from itself. And yeah, I'm going to start from the first one and see if that value is greater than or equal to the value before it. Then I'll add 1. And I'll continue doing this till the end. And my right pass, again, we're initializing it to 1. Now we'll check from, this is n minus 2 because it's the element which comes before the last element, Python stuff. So yeah, if that element is less than or equal to the element after it, then we know that we're increasing the length of this non-decreasing subset, right? So after this, we have both L and R. And now we want to go through it. We want to check one pass where we're considering, I forgot to write that. Right, only, okay, so this is the condition where we're only considering up to that index what the left contribution was. And we can only have L of I minus 1 if I is greater than 0, right? We can't access negative values from an array, so we want to check this condition or else just keep left contribution as 0. And then same with the right, we want to take right of I plus 1, and I plus 1 can go to a maximum of n minus 1 because those are our index values. So if I itself is less than n minus 1, because then, then adding 1 would go to n minus 1 max. So we want to check that. What is the contribution at this index if I only take the left side, if I only take the right side? And we get that from this. So the answer is going to be maximum of what I was getting from the left and adding the 1 value that I'm changing, or the maximum from the right up to this index position plus the 1 value that I'm changing. And now our third condition, as we discussed, is only applicable if, obviously, because I want to access these values, right? So I need to do a safety check to check that I is greater than 0, because I minus 1 can at max go to 0, and I plus 1 can go to a max of n minus 1. So I want to check if it's within these bounds, and I have to check were those two elements beside it from the left and the right, were they in a non-decreasing fashion, right? Less than or equal to. And if they were, then my answer can become a max of whatever answer I had, plus the left side, the right side, and the 1 element that I was changing. So that's where I get answer. So yeah, basically at the end of this, I just return answer. So let's just try this out. Okay, great, it works. Let me just write time was O of n, and then space was O of n as well. So yeah, I hope you guys understood this. Happy coding, everyone.